morning to some of you from Europe. Welcome to Euresys Academy. My name is Yutairi from Euresys APAC Asia, and today with me, Antoine from our R&D team. We will be showing you the bolts and nuts of our Easy Deep Learning Library. This will be the first of 3 training sessions of Euresys Open Division Easy Deep Learning Library. For your information, all the 3 sessions will be made available on Euresys YouTube channel a few days after the last session. So stay alert of our notification. For the presentation itself, presentation material itself, we will also email to you after the 3rd or the last session next week. We have scheduled each session to be 1 hour long, and we will try to respect that as much as possible. However, if we go beyond that, we apologize in advance. There are just too many materials to cover by Antoine. So let's hope there will be no hiccups. Okay, for this training, we recommend that you download Easy Deep Learning Studio from our website. With it, you can do your evaluation, complete from learning to inference phase with your data sets. Do take note, Easy Deep Learning Studio is free to use at no charge. So if you have not done so, please do that, okay? Before we start the training itself, I'd like to take the opportunity to briefly introduce our company for the benefit of those who do not know who we are. So bear with me for 5 minutes. Okay, Euresys started out in 1989 by a number of electronic engineers in Liège, Belgium. It is now, of course, the headquarters for Euresys. The picture you see on the slide is the building we have just moved in recently in Liège. Unfortunately, I have not been there because of COVID restriction. Maybe I get to go there sometime in the future. Besides our HQ in Liège, we have our sister company in Germany, Sensor to Image. We have our sales and support offices in United States, Singapore, Shenzhen, Shanghai, and Japan. All in all, we have about 85 staff, of which half of it are in the R&D team. We are connected to the rest of the world via our distributor network, whom we work very closely with contacts almost daily in many cases. You can go to our website to check who is your local distributor representing Euresys. Okay, our product range, we can break them into 3 categories. We have IP cores, frame grabbers, and software tools. Remember the sister company in Germany I mentioned earlier. Okay, these are the products line that they offer. We have Vision, standard IP cores of GigaVision, USB 3, and Co-Express that works with Xilinx, Intel, and Microchip's FPGA. They also offer IP cores for Sony Pregius and MIPI. So if you want to develop cameras, interface card, or anything that uses the Vision standards, feel free to contact us to find out more. Next, we have the frame grabbers. We have frame grabbers for analog, which is the Piccolo and Domino range, and digital interfaces, which is the Camera Link and Co-Express. Of course, in recent years, with the decline in analog cameras, we mainly ship Coax Link and Grab Link frame grabbers. The last category in our product line is the software tools. This is where Easy Deep Learning resides. Within OpenVision, we have image processing libraries, which you can purchase individually or as a bundle. We have 3D libraries here, Easy3D, Easy3D Laserline, Easy3D Object, and Easy3D Match. Then we have our alignment libraries, Easy Gauge, Easy Find, and Easy Match, as well as Easy Object for surface analysis. We have our readers, Easy OCR, matrix code, Easy Barcode, Easy QR code. And we also have our general library in the form of Easy Image and Easy Color. For the training today, okay, we will cover the 3 deep learning libraries in OpenVision, which is EasyClassify, EasySegment, and EasyLocate. Okay, these 3 libraries are available as a single bundle, as a single Easy Deep Learning bundle, so you cannot buy it individually. Okay, so there you have it, a quick and brief introduction of Euresys. For today's training, we will cover the definition of deep learning quickly. We then show you the basics of EasyClassify, EasySegment, and EasyLocate. We will also show you how to install Deep Learning Studio. It is not difficult, but it is not easy either, especially when you want to utilize a GPU. So we thought it was a good idea to include it in the training. We also take a quick peek at the codes of Easy Deep Learning. Before I let Antoine take over, if you have questions, you can type into this webinar Q&A box, okay? You should see an icon on the right bottom corner of your WebEx. And alternatively, you can email to us on the email listed in these slides, okay? We will then either answer your question at the start of the next session, session 2, or we email to you directly, all right? So without further delay, I let Anton continue with the training. All right, Anton?
Okay, I'm gonna share my screen. Okay. So hello everybody, I am Antoine Najam and I'm here today to talk about the introduction and basic usage of Deep Learning Studio. It will be the first session in a series of 3 sessions about the OpenVision Easy Deep Learning libraries. So today first I'd like to start by a basic introduction about deep learning, what it is, give you a few basic vocabulary to understand various aspects of deep learning. Then I'll try to do a quick comparison between traditional machine vision approaches and the deep learning approaches and see what are the advantages of each one and what can we do with deep learning that we cannot with traditional machine vision approaches. So let's go. So deep learning is part of a family of algorithms which are artificial intelligence algorithm. So artificial intelligence algorithm tries to mimic the intelligence or behavior of humans. And within this category, there is a subcategory called machine learning. Within machine learning, it's a set of algorithms that are capable of learning from data. In our cases here, it is learning from image data. And so deep learning is a family of machine learning algorithms, so algorithms that can learn from data. And these algorithms are based on deep artificial neural networks. So for the purpose of image processing and computer vision, the main deep learning algorithms are called convolutional neural network. So they are usually represented as the image at the bottom of the screen, so as a series of interconnected layers. And so, as you can see here, we have the same schematic representation at the top right of the screen. And I have highlighted the first layer of the network. And just after that, we have the second layer, the third layer, the fourth layer, etc., etc. And so a convolutional neural network is made of several layers. Some of these layers are called convolutional. They are called like that because the operation they perform is actually a convolution. This is why we usually interpret each layer of a convolutional neural network as a bank of filters that are applied on the previous layer. So by a bank of filter, I mean filters such as a Sobel filter, Gaussian filters, etc., etc. However, in the case of deep learning, all these filters will be learned from your data to reach the maximum accuracy for your problem. Also, it is very usual in a convolutional neural network to have the resolution of your input image cut in half at various steps of the network to make the computation faster. This is why you see several subsampling here in between various layers. Also, when we are talking about convolutional neural network, we often hear about different architectures. So what does it mean, an architecture? It is the description of a particular instance of a convolutional neural network. So it will be the settings of all the convolutional layers, how all of these layers are interconnected to each other, the problem we want to solve with this particular architecture, etc., etc. So in the scientific literature, there exist hundreds of different architectures. So for example, there are ResNet, MobileNet, AlexaNet, InceptionNet, etc. And here at Euresys, we have designed custom architectures that we have optimized for industrial application. But of course, they are inspired by the state-of-the-art architectures that I have just mentioned. So now that we have our deep learning architectures, by training them with data, we will get what here we call a deep learning model or tool. And so the deep learning model is really the result of training a deep learning architecture on a specific set of images. And in order to train the architecture to obtain the model, we need images annotated with a ground truth. So the ground truth is really what you want to predict from your images. And this ground truth is different according to the type of library that you will use. So for EasyClassify, the ground truth is simply a characteristic from the entire image. So for example, if it is a good product or a not good product, defective product. For EasySegment, it will be a characteristic for each pixel of the image. So for example, highlight the pixels that are defective within an image. And for EasyLocate, the ground truth is a characteristic for rectangular region of the image. In OpenVision and Deep Learning Studio, these characteristics are called labels. And as we will see later on in the demonstration of Deep Learning Studio, they are quite visible within the interface. So now let's compare a bit deep learning approaches to traditional machine vision approaches. So when you want to solve a new problem with traditional machine vision, first you will capture a few images that are representative of your problem, and you will get a machine vision engineer to analyze these images, try to make measurements or identify various patterns and features within the images. And in a second step, the machine vision engineer will try to create a program and implement various rules to make decisions based on all these measurements and patterns that he has detected in the image. And using these measurements, he can say, for example, if within an image there is a defective product or not. However, it can be quite hard to define exactly what are the rules to perform what you want to do. So for example, in this problem where we want to detect the stones here in the coffee beans, how do we make measurements and find patterns in this image and create the rules after that to find these stones? When the stones can have a shape that are very similar to the coffee beans, they can have a color that are very similar to the coffee beans. So there is a large variety of defects that we want to detect with complex patterns. So this is where the deep learning approach shines. It offers the possibility of, instead of defining all these rules manually and having an engineer try to find how to recognize a stone within coffee beans, you just give images to the algorithm and it will learn from example. So this is really one of the main advantages of the deep learning approach. It will learn and extrapolate the decision rule from real examples by itself. And thanks to learning from real examples, it can deal with very complex images and patterns in your image that you want to detect. Moreover, an advantage of deep learning, and especially for the EasyClassify library, is that it can reuse knowledge learned from other problems. So that means that we can train a deep learning model on some data set, and then we can transfer this deep learning model to improve the result on a new data set. Within the Easy Deep Learning library, it is called pre-trained networks, and we will talk about that again a bit later in this presentation. So, of course, the deep learning approaches has some disadvantages compared to the traditional machine vision approach. In particular, it can require a lot more images than traditional machine vision. Because with traditional machine vision, the engineer that will develop and solve the problem can quickly identify what he needs to do from only a few images. With deep learning, we often have to put a lot of image, capture a lot of image, and it can be quite hard sometimes, for example, to capture a lot of defective products. But there is still some ways to mitigate this kind of need for a lot of image. Also, a disadvantage of deep learning is that it requires usually a lot more processing power, especially to train the deep learning model, but also to use it. So usually you won't be able to process as many images as with a traditional machine vision approach. Also, because you need to capture a lot more images, and it will directly learn from your data, the time you will invest in preparing your images and making sure that your problem is well defined for deep learning, etc., can become really a significant step of your development process. So this is something to take into consideration when considering a deep learning approach. And of course, deep learning, being a technique that learns by itself how to solve a problem, sometimes it can be quite difficult to interpret the decision made by the deep learning model. So for example, human would quickly identify that the image contain a defective product, but the neural network has made the wrong decision, and we don't know why. It can be quite hard to understand why. And so this is really the goal of these training sessions. It is to show how to gain from all the advantages of deep learning and how to deal and mitigate all the disadvantages of the deep learning approach. So now let's go to the second point of today's session. So I will make a quick overview of the 3 deep learning libraries that we have in the OpenVision product. So these are EasyClassify, EasySegment, and EasyLocate. So all 3 libraries work with images. So they take an image as an input, and the difference between the three libraries are what they output as a result. For EasyClassify, the output will be a label for the entire image. So for example, here we have an example of defect detection where there are two labels that we want to recognize, good and not good. For EasySegment, the output will be a segmentation mask. So it will assign various labels to each of the pixels in the image. And for EasyLocate, the output will be labeled bounding box. So in this application, we have identified and located nails and gears in an image. So now I will describe a bit more each of these libraries and talk about a bit about the advantages, the disadvantages, and the limitations. So EasyClassify is mainly an image classification library. It works, it has a limited range of resolution for its input images. It is from 128 by 128 pixels and up to around 1000 by 1000 pixels. One of the main advantages of this library compared to the others is that it can be really fast to annotate, to label all the images in your dataset. Because you only need to assign one piece of information per image, it can go quite fast. Also, for EasyClassify, we have a very useful feature that is called heat maps. We can have a visualization of what an heat map is here. So we have the input image and the computed heat map by EasyClassify. And heat maps are a visual explanation of the deep learning model decision. So basically, what we see here are the pixels that have contributed the most to the decision of saying that this image was not good. And so, in general, it will give an approximate localization for your defect. Also, for EasyClassify, we have the pre-trained network feature that I've talked about earlier. So basically, instead of training a neural network from zero, we initialize a neural network from training that we have done here at Euresys on a very big data set. And it allows you to get results faster. And also, sometimes this allows you to get results with a smaller data set that otherwise you wouldn't have any good result at all. The two main use cases for EasyClassify are defect detection and product recognition. I also invite you to look at our datasets in the deep learning additional resources that you can download for free on our websites. It contains various datasets and deep learning studio projects that you can test with Deep Learning Studio. So for EasyClassify, we have 3 datasets in the additional resources. All 3 datasets are defect detection application. So this is the minimal stone tiles and copper silver tape dataset. Some of these datasets show how to recognize multiple types of defect in your image. For example, the stone tiles are 4 types of defect. So let's go to the next library, EasySegment. So EasySegment is an image segmentation library. As I said, the output of this library is a segmentation mask. There is 2 modes for EasySegment, the supervised and unsupervised mode. They work quite differently. So I will go just after this slide more deeply for each of the mode. But basically, the supervised mode requires a ground truth segmentation mask. So you need to tell the algorithm what is the label of each pixel. And in the unsupervised mode, you only need a good image. So the unsupervised mode can only be used for defect detection, anomaly detection, and you only train with good products. Also, one of the main advantages of the EasySegment library compared to EasyClassify and EasyLocate is that it can work with a very large range of resolution because it will automatically divide your images into sub-images internally. And so the supported resolution of input image goes from 64 by 64 pixels and up to 10,000 by 10,000 pixels. The main use cases for EasySegment are defect detection and localization and product recognition. So let's talk a bit about the unsupervised mode of EasySegment. So as I said, the model will be trained only on good images. So the main advantage of that is that you can very quickly annotate your dataset, and you can have an incomplete dataset that contains only good images. Of course, it will be always best to have also a few defective images to evaluate the deep learning model that you train and to see if it is really able to detect defects. So the unsupervised mode is also called an anomaly detection algorithm because it finds pixels that deviate from the good model it learned from the good images. And it has an ability to detect defects that were unknown at training time because it doesn't learn to recognize defects directly, but try only to find deviation from what it thinks it is good. And so in principle, it can detect defects unknown at training time. The unsupervised mode works best with complex natural patterns, such as the fabric dataset that you can find in the additional resources. So there are many advantages to the unsupervised mode. It can be quite easy to use. However, it will be usually less precise than the supervised mode, and it is incapable of detecting some types of defects due to the way it works internally. In particular, defects that look like parts of the image elsewhere, parts that are good in the image. Also, defects that look like the image is blurred, or positional defects. So for the supervised mode, here we will annotate each image, and we will say this pixel is product A, this pixel contains a defect, etc. Whatever you want to solve with EasySegment supervised. So it is really a precise and powerful tool. However, the labeling of the image, the annotation of the image, can be very time-consuming because you need to assign a label to each of the pixels in the image. However, it has a large ability to recognize complex patterns that are very similar to the background, such as the stones in the coffee bean that I showed earlier. Also, it can recognize multiple labels within the same image. So for example, if you have different types of defects that you want to segment, different products that you want to segment, the supervised mode is able to do that. Also, within Deep Learning Studio, we provide results analysis at various levels, at the pixel, blob, and image level that gives you various possibilities to analyze and understand your results. So this is an example of EasySegment supervised, where we have segmented the two stones here. We have a larger resolution images here. Okay, now let's talk a bit about EasyLocate. So EasyLocate will locate objects using bounding boxes. So an object is really an abstract term within the EasyLocate library. It can be pretty much anything that you want to detect in the image. It can be a defect, a product, any kind of pattern or feature that you want to locate in the image. Similarly to EasyClassify, it has a limited range of resolution for its input images that goes from 128 by 128 pixels and up to around 700 by 700 pixels. one of the main advantage of EasyLocate compared to EasyClassify and EasySegments is that it can work well with occluded or overlapping objects. So EasyLocate will work at the instance level. So it will try to locate each instance of an object, even if it touches another one. This is why one of the use cases for EasyLocate is counting application. So if you want to know the number of a specific object that you have in your image. You cannot do that with EasySegment supervised, for example, because with EasySegment supervised, if you have two nuts that touch each other, there will be one blob detected in the image, and you won't know how many nuts there was in the image. So this is one of the main advantages of EasyLocate. Also, it can recognize multiple labels within the same image. So here we have an example where EasyLocate is able to recognize nut, bolt, and washers. So the other use cases for EasyLocate are defect detection and localization, product localization, and package verification. In our deep learning additional resources, we have two datasets, the electronic components bag, which shows some kind of package verification application where we want to identify which components we have in the transparent plastic bags. And we have also the ceramic capacitors, which more demonstrate a counting application where we want to know how many ceramic capacitors we have in the image. So now let's go to the introduction about Deep Learning Studio. So first I will say a few words about the software. I will show how to install it, and then I will do a live demonstration and explain how to create a model with Deep Learning Studio. So Deep Learning Studio is our main program to prototype, train, test all your deep learning models for OpenVision. It is free of charge. You can download it directly from our website and do how many training you wish. Annotate your images directly within Deep Learning Studio. Also, it is project-based, so you can go back to your work quickly, and it will save automatically all your annotation, your tools, the results for each of the tools, etc., etc. So you can configure, train, and evaluate all your tools within the Deep Learning Studio application. It is from the Deep Learning Studio that you will export your models for your production environment to use with the API of Easy Deep Learning. And the software works on Linux, Intel, and Windows. We advise to have quite a strong computer for using Deep Learning Studio. So an i7 or i9 Intel CPU, at least 16 gigabytes of RAM. Especially if you want to train an NVIDIA GPU is usually recommended, and with at least 6 gigabytes of dedicated RAM for the GPU. Also, Deep Learning Studio requires a screen resolution of at least 1920 pixels by 1080 pixels. So let's see how to download and install Deep Learning Studio. So I have a small video here that shows where to download Deep Learning Studio. So you go to the Euresys website, support download area. Then you go to the OpenVision libraries. There you can select the version of OpenVision that you want to download. You click on the plus sign, and there you have several packages and set of files that you can download. For the Easy Deep Learning libraries, you can either download only the Deep Learning Studio package or the full OpenVision package that also include Deep Learning Studio, but also the API and all the other OpenVision products. As I said earlier, I really advise to download also the deep learning additional resources. You can quickly test on the dataset that you provide if everything is set up correctly on your machine, and you can quickly test and see how the software works. So also, if you have an NVIDIA GPU on your computer, you will need to install and download the CUDA libraries. So you need to download the CUDA toolkit version 11.1 precisely. So for that, you need to go to the CUDA toolkit archive website. You select the appropriate version. You select your operating system and version of the operating system, and then you can download the installer. And then you simply follow the instruction of the installers. You also need to download the NVIDIA CUDA Deep Neural Network library, also called QDNN. And you need to download version 8.1 for CUDA 11.1. So you need to go to the archived QDNN releases website. You will need also to subscribe and log in to the NVIDIA website to download QDNN. And then you just have to find the appropriate version for Deep Learning Studio. And there you can download, for example, the QDNN for Windows and follow the instructions that we have in our user guide to install correctly QDNN. So be really careful when installing CUDA and QDNN, because it is one of the main bugs that we see when using Deep Learning Studio. So if there is a mismatch between the version, it can cause silent crashes. Also, it is good to know that you can install more than one version of CUDA on your computer, so that if you have other software that use a different version of CUDA, then it's okay. You can install several versions on your computer. And also be careful that CUDA can install GPU drivers. And so the drivers that it installs can be incompatible with higher CUDA version if you have another CUDA version installed on your computer. Okay, so now I will try to do a live demonstration of Deep Learning Studio. So first, I will stop sharing my screen. We'll start Deep Learning Studio. Okay, and share my screen again. Okay, so when you open Deep Learning Studio, you get to the recent projects dialog. So it is the project that you have opened recently. Here I have opened recently all the projects that are in the deep learning additional resources. So you can see the mini waffles datasets, stone tiles dataset, for example. I just need to double click on any of those to open. I can also directly open a project by clicking here. And for example, here I can go to the stone tiles, and I just have to open the stone tiles edlproj file to open the project. As you can see, a project is made of one file and several folders. So we have an image folder where all the images are copied and imported. And we have one folder per tool that contains several files that represent the train tools. And also a result folder that contains all the results for this tool. So if I open this project, we see that Studio opened the project, and we see directly the list of image, the list of label that we want to recognize. So as you see, there is 3 defect label for the tone style dataset. I can click on image in the list to display it in the image viewer next to it. And when so you can see that the main interface of Deep Learning Studio is organized around 6 tabs, which more or less represents the steps that you need to do to get to your final production model. So first, you need to create your dataset. and annotate all your images, or at least part of the images in your dataset. The second step is to create splits. So a split is a division of your dataset into 3 parts, a training part, a validation part, and a test part. As we'll see in the next 2 sessions, it's really important to split your dataset to get a good estimation of the performance of your tools in production. The third tab is the data augmentation tab. So data augmentation is a way of performing random transformation on the image. And it allows you to artificially increase the number of images in the dataset. It usually makes your models more robust by using data augmentation, because you can introduce various symmetries or transformation that the deep learning model will be able to handle. The fourth tab is the tool tab. It is where you create, configure, and train all your tools. So you can create as many tools as you want. The fifth tab is the validation and result tab. So this is where you can select a tool and look at the results for this tool. So here we have various metrics and tables that you can use to filter the image list, for example, and to analyze where the model made mistakes. And finally, we have the inference test, where you can quickly load a few new images that you have kept apart and compute the results using one of the tools on these images. So let's try to do all these steps by creating a new project and doing the annotation, trying to train a tool to see how it works really. So I click on New to create a new project. So when we create a new project, we need to specify its name, its path, and the type of project. So here I will create a mini waffles project. So I name it mini waffles. It will be an EasyClassify project. You can select also the other libraries if you want. You have also the description and various limitations and constraints of each of the tools. And by default, the project will be saved in a folder in your documents folder, Euresys Deep Learning Studio Projects folder, and then the name of the project. So there I have created the project. By default, it will contain no images, and it contains a single label that is default. Also, as you can see here at the top left of this tab, we have import images into project directory that is checked by default. If you intend to work on several computers with the same project, or work with several people on this project, you need to leave this option checked. What it does is copy all the images that you add to the project into the images folder, and it allows you to move the project to another computer without any problem. So here, my first step will be to add images. So I will go to my old mini waffles project and select all the image. So I do a Control A to select all the image in this folder. And here I can add all the image in the dataset. So as you can see now, we have 463 images in the dataset, but all of these images are unlabeled. This means that we have not any ground truth for the images. So before annotating all the images, we need to define what we want to do with this dataset. What do we want to recognize for this particular image? So this is done in the image labels. So we need to define the list of characteristics that we want to recognize in the image. So in this case, it's pretty simple. It's a basic defect detection case. So the two labels will be good and not good. So you can also change the color associated with the label. So for example, we can put the good label in green and the bad label in red. As you see, the image count for each of the label is still 0, and we have still 0 labeled image. In order to label an image, you can click here on the image, and you can select the appropriate label. So, for example, this one is a bad image, as you can see in its name. You can also see the part of the waffle is missing. So it is a not good image. So here, in order to annotate more quickly, and because I know that all the images are correctly named, so all the not good images have bad in the name, I can directly here tap type bad. It will filter all the images by the name. And so here I only have image files that have bad in the name. So it allows me to select all the images in the list. So all the images that have bad in the file name, then I can do a right click, set label, not good. As you can see, we have now 222 images that are labeled, and these 222 images are all part of the not good label. So now I can do exactly the same with good images. I search for good. I select all the images using Control A, right click, set label, good. And now we have 463 images that are correctly labeled, and we have 241 good images. So the second step is to go to the dataset split tab. So we need to create a new split. So we can name the split. By default, it's named split1. And then we can choose the number of images in each set or the proportion of images in each set. So the image will be randomly selected to be part of each of these sets. So by default, it's 70, 20, 10% proportion of the dataset. So I will leave it by default. And so if I select the split, again, I see various statistics about this particular split. And I see also the dataset split for each image individually. The third step is to configure data augmentation settings that are good for your specific dataset. So by default, there is an anti-data augmentation settings that do not perform any data augmentation, but we can create as many settings as you want to perform various tests, for example, in data. So if we select an image here for the image viewer, we can also have various visualization of the data augmentation settings that we have set. So for example, here, because the waffles are more or less a circle, we can introduce a 180 degrees rotation. And so if I click on random rotation, then it means that during training, we will perform a random transformation between plus and minus 180 degrees before training with this image. So we can also do vertical and horizontal flip. And just these three settings can be enough for this dataset. So the fourth step is to go to the Tools tab, and I will create a new tool. So by default, you see that the tool is not trained. I will leave all the settings by default. So you see that here, the only split that we have created was selected automatically. Here, I will select the data augmentation settings. I will train for 50 iteration because maybe we do not have time to do long training here. And then I simply click on train, and the training is started. As you can see at the top of the screen, we see processing one task queued. What it means is that we can launch several tasks concurrently. So if I add a new tool, I will also say 10 iteration. I can start the training here, and it will be put in the queue here. As you can see, we have the tool 1 is currently training and tool 2 that is waiting for the GPU. We can launch as many training as we want concurrently. As you will see, the first tool is already trained and the second tool is currently being trained. And also, we order the list of tasks that are waiting to be processed. So that if you have a new experiment that you want to do and do quicker, you can put it higher in the processing list. So as you can see, small training with 10 iteration can already give a pretty good result. Here we have 97% accuracy on the validation set. And it was done in only a few seconds on a laptop GPU. So while Deep Learning Studio is training various tools, we can already go into the next tab, the Validation and Result tab, to look at the result of the tool that I finished training. So here we can select the tool for which we want to see the result. So we leave at result at tool 1. We can also filter by the part of the dataset that we want to analyze, so training, validation, or test set, or the sets, all the images together. And then we can analyze and see where the model made mistakes. So here we have a good images, so an image that we have labeled as good, but that was predicted as not good. And we see in the result, we have a probability list for each of the labels. And we see it's more like 50-50. So the model did not know really which label it was. So maybe training a few iterations more would help the neural network get more clear-cut result in this case. Also, we can display the heat map, which will show more or less an approximate localization of the defect. So as you can see here, it already shows quite accurately a missing part of the waffle. So finally, we have the inference test tab, where we can add new images or add a folder of image. So let's say I want to add a single image. And then I can compute the result for this image. So I will click on play to compute the result. However, there are currently tools that are training in the Tools tab. And so the result computation that we have launched here need to wait for the tool to finish. So I can stop here. And now we have the result that is already computed. So I can also display the heat map. I can go to result here. We have the probability list. We have the processing time of 4 milliseconds. We can have also various characteristics for the image. So maybe let's open a few datasets, like an EasyLocate dataset, to look a bit at the images. Oh, I'll just add a new object. So as you can see here, this is the annotation for EasyLocate. I can look at the labels that we have assigned. And if we go to the validation and result tab, we can look at the result for each image individually. And here are the results, for example, for the EasyLocate library. So when you are happy with the result of your model, you need to go back to the Tools tab and export your model by clicking on the Export button. And then you will export a deep learning tool, an LCL file that you can open with the deep learning API. So I will return to the slides and to talk a bit about the usage of the API. So I stop sharing this and I will share slide. Okay. So here we have a few slides that describe the Deep Learning Studio user interface that I just did using the live demonstration. And now we arrive to a quick look at the C++ and C# API of Easy Deep Learning. This will be the last part of today's sessions. So the first step when you want to create your own program that use Easy Deep Learning would be to export your tool, such as I just showed in Deep Learning Studio. And then you need to use our API. So we need to create an object for the type of tool that you want to use, load the model that you have exported using the load method, configure a bit the tool, whether you want to use the GPU, for example, or not. And here at the bottom of the screen, we have a table that shows the class name, method name, and result type for each of the library that we have in Easy Deep Learning. So for example, for EasyClassify, the class name is EClassifier. So you need to load the model that you have exported on an EClassifier object. You need to call the classify method with the new images to obtain an e-classification result. So let's have a quick look at a small code snippet in C# and C++ that does exactly the same thing. It will load a classifier, classify a new image, and check the result of the image. So the first step is to declare a classifier object of type eClassifier, and then we load the model that we have exported from Deep Learning Studio. Then here we decide to use the GPU, so we enable it. And now we can already use the classifier. But before using it, we need to perform image acquisition. So here I'm only declaring the image. The image acquisition really depends on your application and your setup. So it can be capturing an image from the camera, or you can load also an image from the hard drive into the image C24 type. Then, in order to use the tool on the image, you simply call the classify method on the classify object and give it the image. We will get an e-classification result that we name R. And then from this result R, we can analyze what the neural networks detected. So for EasyClassify, it returns basically a list of probability for each of the label. And we have a method named getBestLabel, or bestLabel in C# that returns the label that has the highest probability. So this is the most probable label for this image. And so here we can do if-else construction to check if the best label was good or not good. And then we can implement the logic of your application within this if-else construct. For example, decide to move away the not good product from your production line. So thank you very much for your attention. I will pass the mic to you to conclude this first session.
Okay. Thank you, Antoine. That was very helpful for me. I hope today we were successful to show you the basics of Easy Deep Learning, particularly Easy Deep Learning Studio, to get you going. It will get more deeper in the next two sessions. If you have any questions or feedback from today's session, our line is always open via our sales and support email that is showing now on the slides. Okay, please feel free to email to us. Okay, we will reply to you either directly or at the start of next session. All right. We will have the next session this coming Thursday on September 1st, same time. In this next session, we will show you how to maximize and optimize your data. We will give you tips to decide which of the 3 tools to use for your data sets. We will also highlight the criteria and the quantity of the images needed. We will also cover how to annotate the images. And finally, Antoine will talk about data set splitting and augmentation. All right. I think we are a little bit, we are on time actually. So I hope to see you on Thursday. Bye-bye for now.
Bye.
Bye.